Hey team, Sid here, and welcome to Getting Started with Kubernetes. This is going to be a quick guide that takes us through the basics of getting some code running on our system and then deploying it into a Kubernetes cluster. We're going to keep things pretty simple, and on the screen here are kind of the basic steps. I'm going to create a simple application using Python. I'll containerize it. I'll push that to a container registry, create a cluster, define the Kubernetes resources associated with my application, apply those resources within the cluster, and then set up the necessary DNS to actually allow traffic to reach my application. This is a video within the broader context of my Kubernetes Platform Playbook series. So far, we've talked mostly with theory, but I wanted to get hands-on and just show you what it takes to get an application running in Kubernetes. We're going to do things pretty quickly today. We're not going to do everything in the state that they will eventually be in that platform that we're going to be building. But I just wanted to run through from scratch, getting some of your code running in a Kubernetes cluster. Rather than taking some existing container and deploying it into Kubernetes, I think it's more educational to actually create that custom image ourselves, even if it's quite simple. Today I'm going to be using a Python package called FastAPI to create a super simple API application that will then bundle up. The very first thing I'm going to do is to create a Python virtual environment. Now this video is not about how to manage your Python dependencies and use virtual environments, so I'm just going to do it this basic way by saying Python 3 venv, and I'll put that in the venv directory. So this created a local directory called venv, and that's where it's going to install my local packages. I do need to activate that virtual environment, so I can source the file venv bin activate, and now we can see that my Kubernetes Getting Started virtual environment is activated. There's a couple of packages that I'm going to install, so now I'm just going to do pip install FastAPI. We're also going to install Unicorn. That's the web server that we're actually going to use. And so we now have those two packages. We can do pip freeze to see all the sub packages that it may have installed. And so I'm just going to create a requirements.txt file with two things in it. This FastAPI and the Unicorn package. And hopefully I'm pronouncing that right. So I'll do code requirements.txt. Great. And the two things that I want in there are FastAPI and Unicorn. Rather than pin all the way to the patch version, I will do this. And that will allow it to automatically upgrade if it needs to, but only at the patch version level. So now if I do pip install -r requirements.txt, it should say that all the requirements are already satisfied. Great. At this point, I'm just going to go through the most basic application intro here. Example, create it. So we're going to create a main.py file. I'm going to do so within an app directory. So I'll do make dir app, cd app. We're going to code touch init.py. And then we're going to open up a main.py. And this is going to be where our actual application lives. And so I'm just going to paste in that code from the docs. I'm going to make it even simpler. We're just going to have the hello world for now. And that means we don't need the import from the typing package. There we go. We're going to actually run the server with Unicorn. So I'll just copy this command and then run it here from within that app directory. Now it is running on port 8000. So if we go to our browser and access localhost 8000, great. We can see our application. I can change this to be something else. Hello YouTube. Save it. it restarted our application, and now if I refresh the page, we get the new updated response from our API. Great. So that is the basic application that we're going to use. In order to deploy to Kubernetes, we need to take this and put it inside of a container. So Kubernetes can run pretty much any workload, but the requirement is that it only knows how to run containers. So rather than running this locally on a virtual machine somewhere, we are instead going to bundle it up as a container and deploy that container image as a container on Kubernetes. So in order to do that, there's actually some good documentation in the FastAPI page here about how to run FastAPI inside of a container. Good background here. If you're not familiar with containers, I would read that. And if we get down to here, we see pretty much the same code that we were using before. And then it gives us the sample Docker file. So I'm going to create a Docker file. So I'll kill our server. Great. At the top level, I'm going to do code Docker file and paste in their sample code. And so if we just go through and look at what this is doing, it's taking a base image. So this is a publicly available base image that I believe is Debian based, running Python 3.9. It's setting up a working directory. So this is where inside of the eventual system that we're deploying, it should use as the working directory. We then copy in our requirements.txt file. So that's this file here. And the reason that we copy it in first, before we copy in the rest of our source code, as we build container images, each individual step is cached. And so by copying this in separately from our source code, which we copy in here, we can take advantage of that caching such that we only have to reinstall our dependencies if we change one of those dependencies. If we instead copied in all of our code first and then did pip install every single time we changed our source code, we would need to modify or rerun this step when we build the container image. We then run a pip install, and so it takes that requirements.txt that we just copied in, installs those dependencies. We then copy in our source, and so because I placed it in this app directory, it will get copied in at the root/code/app directory inside the container. And then finally, we specify the command that should be run when we actually when we run the container. In this case, it's similar to the one we had before, but now we're also specifying that we want to run on port 80 instead of port 8080. So I can do a Docker build, and then I'll specify period to say, hey, run Docker build against the Docker file in my current working directory. As we can see, it's going through step by step and executing these commands. Great, so that container image is now built. One thing that we didn't do there is tag it in any way. And so I'm going to rebuild it, but I'm going to also add the -t flag here, and I'm just going to call it for now. I'll change this tag in a bit. Kate's FastAPI. We'll see that this time it's going to build much quicker because we already have all those layers cached. So this should only take a second. Now we have that container image built locally, and we can run it locally as well. And so I can do a Docker run, and then if we give it the name of that container that I just tagged, so Kate's FastAPI. But one thing I do want to do is port forward from my localhost 8000 to the port 80 inside that container. So up here, we're telling it to run on port 80 inside the container. In order for me to be able to access the network inside that container, I need to connect my MacBook with the host of the container itself. And so by doing so, with this -p flag, I can now run this. It's going to run my web server inside of that container, and now I can access it like before on port 8000. So I refresh the page, and we get the same response. Just to prove that it is indeed working, I'm going to switch this to use an environment variable. So I'm going to say import OS. And then here, let's just do hello, and we'll do from, we'll make this an F string, from, and then rather than YouTube, we'll put this, and I'll say os.environ.get, and we'll look for the end flag, and if we don't find, or we'll look for an environment variable named env. If we don't find it, we will return default env. And these will actually need to be single quotes because we're inside of that outer double quote. We'll rerun our build command. Then we'll rerun our run command. And now if we load here, we can see we didn't specify the environment variable when we ran our container, and so it shows up as default env. Great. So the next step is to get that container image into a registry where we'll be able to use it from a Kubernetes cluster. And so there's many registries available. DockerHub is one of the most popular. Let me go ahead and get signed in here. I'm going to create a new repository for this image. We'll call it Kate's Getting Started. Create. And so now we're going to need to tag this with this tag when we build the image. So we're going to do build. So instead of Kate's FastAPI, we now need it to be this. And then for tag name, for now, I'll just do 0.0.1. Then I can push that tag. So it exists locally, but I need to get it to DockerHub. So I'll do docker push on that tag. It now is taking the container image that I have built locally, pushing it out to DockerHub so that we'll then be able to use it. And because it's a public image, anyone could pull this and use it. And if it was a private registry, we would have to do some additional work on the Kubernetes side to make sure we could actually access that. Now, if we refresh over here, we should see that the image shows up with that tag. Awesome. And so we've created a super simple Hello World API. We bundled it up as a container image. We've pushed it to a registry. And now we can create a cluster to actually deploy this into. So one of my favorite places to deploy a quick cluster is Civo Cloud. It's a Kubernetes focused cloud provider. I'm going to go ahead and log in. And one of the nice things about it is that you can launch a cluster very quickly. It only takes a couple of minutes. And so I'll do Kate's Getting Started. We're going to spawn it with 3 nodes, sure. We'll create it with a new firewall. We're going to leave access to the Kubernetes API on 6443 open. You could lock it down so that only my IP could access it. We also are going to enable HTTP traffic coming in, and that's going to allow me to access this service because eventually I'm going to set it up so that we can access it from a public domain. For the sizes, I'm just going to pick these small nodes. I'm not going to leave this up for very long anyways, and that looks good. In terms of advanced options, I'm just going to leave it as the default. This is networking stuff. And then on the marketplace, it does install Traffic, which is a ingress controller by default, as well as a metrics server, and that's to enable accessing metrics about things running in the cluster. We're going to end up using Traffic as a way to get traffic from the outside world into our application. For now, that's all I'm going to do. I'm going to click Create Cluster, and it should create here in a couple of minutes. In the meantime, I can go ahead and create the corresponding definitions for how we want to deploy this into Kubernetes. And so I'm not going to go in detail into the reasoning behind Kubernetes or what it actually is. I have some other videos that talk about what Kubernetes is, whether it's right for you, whether you should self-host or use a managed clusters. I'll link to some of those in the description. But for the sake of this video, I'm just going to go ahead and define the resources, how we're going to deploy them. And so I'll create a new directory called Kubernetes. We'll go in there. And so we're going to have a few things. We're going to run our code in what's known as a deployment. And so at the lowest level in Kubernetes, you deploy a pod. A pod is a collection of one or more containers that are running together and share certain aspects of things, including networking, so you can access each other on localhost. However, you never want to create and interact with pods directly. There are higher level constructs that allow you to create what's called a deployment or a stateful set. And that deployment, you can specify whether you want one or more replicas of a particular pod configuration. And then Kubernetes will look at that deployment, create what's known as a replica set. And so a replica set is kind of in between the deployment and the pod. It's a specific configuration of that pod. And then from that replica set, Kubernetes will maintain however many copies of the application that you want. And so in this case, we're going to create a deployment. And so I'll do code. And I'm going to start from the Kubernetes documentation on the deployments page. It's going to give us a basic deployment here. I'll just paste this in. And then we're going to change a few fields here. So their sample is running an Nginx web server. In our case, we want the image that we just tagged and pushed to DockerHub. So I'll copy this. We're going to use that image. This is going to be FastAPI. FastAPI. We don't need to name it deployment because that's what it is. We'll say it's in the FastAPI app. We will run 3 replicas. That's fine. We want this to match there. The container port is port 80. That's where we told FastAPI or Uvicorn to run inside our container. And this is telling me that I don't have resource limits. So one feature of Kubernetes is you can tell it how many resources a particular pod or a container within a pod should consume. And so we can create a resources section. And then within that, we can have requests, and then for requests we can have CPU, and let's say this takes 200 millicores, so 1/5 of a CPU. That's fine. And then for memory, we can say, let's say it's going to take, I don't know, 300 megabytes. Cool. And then for limits, I'm not going to specify a CPU limit, but I will tell it that we don't want the memory to go over let's say 400 megabytes. Okay, that should be sufficient to run our application. We basically are telling Kubernetes, hey, we want to create a deployment. The deployment lives within this API version, so each type of resource will have an API version associated with it. This just happens to be the one that deployment lives under. We give our deployment a name, and then we also give it labels. And so these labels are going to be useful later when we want to route traffic to our deployment. We're going to need to be able to use those labels to figure out which pods we want to assign or route that traffic to. And then within the deployment, we specify, here's our specification. There's some things that live at the deployment level, such as the number of replicas. Again, we can use this, this selector field is what tells the deployment how to figure out which pods to manage. And so that's why we have this match labels here. And then we have that label applied within the template itself. This template is a template for each pod that the deployment is going to create. And so we've got our label there, and then we have our specification for the pod. And so in the pod, like I said, it's one or more containers. In this case, we just have one. We're naming that container FastAPI. We're specifying the image that we push to DockerHub. We're going to allow access on port 80 with that ports field. And then I specified the resources that this container is expected to and allowed to utilize. So that should be sufficient. We're also then going to need to specify a service. And so a service is basically like an internal load balancer inside the cluster in front of our deployment. So if we've got more than one pod, we can have a stable internal address to use to address those pods. And it will load balance across the multiple replicas. And so I'm going to create a service.yaml. Again, I generally just go to the official documentation. I'll go here, here. It's relatively simple to define a service. In this case, we will go here, paste it in. I'm going to call it FastAPI once again. And then we're going to want our selector to match the labels that we are applying to our deployment. And so in this case, I'm going to change this to selector app FastAPI. TCP is fine. And then we're going to use port 80 for both the port and the target port. So incoming traffic on port 80 is going to go to port 80 on those pods. And again, that makes sense because that is the port we're listening on, and that is the port within our container that we're running our web server on. So we've got our deployment and our service. It is likely that our cluster should be done setting up by now. It's been a couple of minutes, so I'll go back to Civo, and we see the cluster is now running. I'm going to download my kubeconfig file. So this is a config file with the credentials necessary to access the cluster. Like it is warning here, this file has essentially the admin config. And so you would want to protect this very carefully. And eventually you would set up additional users within your cluster with more limited permissions such that not everyone needs admin access. So I'll download that kubeconfig file. Great. Then I'm actually just going to put that alongside my application. In an actual setting, I wouldn't put my admin credentials here in this folder, but for now, that should be fine. I'm just going to call this kubeconfig, Civo kubeconfig. And then you'll want to install kubectl, which is the command line for interacting with Kubernetes. And specifically, we need to tell it how to find the admin config that we just downloaded. And so in this case, it is up a level. We're here. And you can set the kubeconfig environment variable. And so I'm going to export that. And that is just going to be my present working directory. And then Civo kubeconfig. And so now when I do a kubectl get nodes, it should show me the 3 nodes running in my cluster. So we see they've been up for 11 minutes. We're running version 1.22.11. And that looks good. Let's go ahead and apply our configuration to the cluster. So now I have everything I need to do so. I've got my deployment, I've got my service, and if I do from that Kubernetes directory, kubectl apply -f for file, give it the local directory, it'll apply all the files within this directory. And so we see it created both my deployment and my service. And now if I do a kubectl get pods, those 3 containers are creating. It was able to find those in the remote cluster. And so I'll do a -w for watch, and it'll actually sit here and update me anytime the status of one of those containers changes. Okay, we've got one of our 3 running. The others should probably change soon. And now, just to show you that they are indeed running and doing the same thing that we expected before, I'm going to go ahead and port forward and I can port forward from my local system to the Kubernetes cluster. So I can do kubectl port forward, and then we'll want to port forward, let's say, to this specific pod. And I'm going to go from 8080 to port 80. And so this is saying from my local 8080, I'm now forwarding to 80 inside the pod. So before we were on 8000, now we're on 8080. So 8000 is no longer running. If I go to 8080, that request will be forwarded into the cluster, and we get back our default environment. One thing we can do is specify an environment here inside the pod. And so let's say at this level, we can say env. We'll have a name, and this is going to be env, and then we're going to have a value, and our value is going to be Civo. Now I can reapply my definitions. That new deployment will be configured. If we then look at the pods, we'll see that the old ones are being deleted and new ones are being created with that new environment variable. We've got our new pods up and running. And so now if I port forward again, we'll be accessing one of those new pods, except I need to get the new name. And what we expect is when we refresh this page, now instead of default env, it'll show us from Civo. Awesome. And so this is kind of following best practices of keeping your configuration separate from your application. So if you're familiar with the 12-factor manifesto from Heroku, that's a key component of that, is breaking out your configuration from your application itself. And so in this way, we're able to do things like use environment variables. There's what's known as config maps and secrets within Kubernetes, where you can define things such as your credentials or additional configuration that will modify how your application actually runs. And so just showcasing how you can load in configuration at runtime here with this environment variable and give a different behavior for your application. And so the final thing that we want to do, yes, our code is running in the cluster, that's great, but it's currently not accessible to the world, right? So we need to figure out a way to get traffic from the public internet into our cluster. And so in order to do that, we're going to use what's called an ingress. And so there's an ingress type controller. And that is going to allow traffic from the public internet. It's going to hit our cluster. It's going to get routed according to the rules that we define. It's going to hit our service that we define and eventually end up on one of our pods. And so here, like I said, when we were provisioning the cluster, we have traffic as our ingress controller installed in the cluster by default. And so if we look at the documentation for it and take a most basic configuration, once again, we'll do code ingress.yaml. They have this production namespace. We didn't use a namespace, so everything actually that we've deployed so far is in the default namespace. And so we can see there's the default namespace, there's kube system, kube public, and kube node lease. Generally, you would want to organize your applications into different namespaces so that they can be isolated from each other and logically grouped. But in this case, we just use the default namespace. Here, we're not actually going to have separate paths for separate services. We could do that, and eventually you would if you had multiple backend services. You might have /bar go to one of them, /food go to the other. And so this ingress resource allows you to have a single external load balancer and route traffic based on different paths that you specify. In this case, though, we're just going to route the root path. And the backend is going to be the name of our service that we use, which was FastAPI. And we're going to route on port 80. I'm going to set up a subdomain of, let's say, DevOps directive. So in this case, I'll do kates.devopsdirective.com. And that should be sufficient. I'm going to name this FastAPI as well. And so I will do, once again, the apply. We created our new ingress resource. The one thing we do need to figure out, though, is the public IP address of our cluster so that we can route traffic to that. In order to get that public IP, I'm going to go here to the admin interface over here, and we see that we have this external IP right here. And so now I'm actually going to go to Cloudflare, where I have my DNS set up for DevOps Directive. I will log in. Yeah, so if I go to DevOps Directive, and then let's create an A record. So we'll go to DNS. We will add a record, and this record will be for Kates. And then we'll paste in the IP address. Save. And so now kates.devopsdirective.com, once that propagates, we'll be going to that location. And as you can see, we just accessed that and it took us to our application. So now we have a public endpoint that's routing traffic to the cluster. That ingress is routing traffic to our service, which is routing traffic to our pod where our application code is running. And so that's kind of an end-to-end example of how to get code from your system and run it in the cluster. One neat thing we can do is to actually display the pod name here so that we can showcase it load balancing across those. And so the way that I'm going to do that is within my application here, instead of just using this, I'm going to use host name. And so host name is what the pod name is going to be inside that running container. This means that I need to rebuild my container image, re-push it to DockerHub, and then deploy with that new version. And so let's just go through that workflow real quick. So if I do my docker build command, I'm going to bump this to 002. I was in the wrong directory, so I'll bump it to 002. Great. Now I'm going to push the new image. And this type of thing where you're building container images, updating which one is used in your deployment, ideally that stuff's going to live in a CI/CD system so that you're not doing this manually, because it can become really easy to make a mistake. But just for the sake of demo purposes, I'm going to just modify this here. Our new image is in DockerHub, and so now I just need to reapply this configuration. So I'll go into my Kubernetes directory and then rerun my apply command. And then if we do a kubectl get pods, we'll see, okay, 2 of them have already cycled. This is the old one. It'll be gone here in a second. All of them are gone and should be running our new version. And so if we can actually look at the definition of what's running here and say kubectl get pods, name of pod, and then -o YAML for the output format YAML. If we look at the image field inside of our container here, if we can find it, here is the image, and we see that it has version 002 applied. This image pull policy is another field we could have defined on our deployment, and that would say, when should we pull the image from DockerHub? For each node that is running, it'll pull that container image if it's not present. If it is present, it would use that cached version. So we need to be careful if we're using if not present, if we're modifying a tag in place with a new code version, it could cause us to not get that new code version. So it's always best practice to kind of treat container image tags as immutable and always increment when you're deploying into a cluster. So now if we refresh here, that traffic should be hitting the new version of our application and should show us the name of the pod. Looks like it didn't get picked up. And so why would that be? One thing we can do to debug is let's actually go into the container. We can get an executable environment inside the container, get pods, kubectl. We can do exec and then -it for an interactive TTY session. We'll do name of pod, and then we'll just execute bash as the thing that we're doing. And the actual newer command is to put -- here, just so we don't get that warning. And then let me do echo host name. So that is what we wanted to show up. And so why, when we looked in our environment, did we not get that? So if I do, let's just get a REPL for Python. Oop. So now we're in Python. We'll import os, os.environ. I need to spell it right. Because, okay, so I was using sort of bash syntax. We actually just want to get the key host name. Do print. Oh, it is all caps. Great. And so removing that $, then we'll save. Once again, we need to push a new version of our code. And so as you can see, this is the type of stuff you would want to test locally, test within your continuous integration. So you're not having to iterate and push new container images and deploy those into the cluster. In a future video, I'll get into sort of what a normal development workflow would look like. This is just meant to demonstrate how to get code running from your system in the cluster. But there's much more effective developer workflows that don't require this sort of slow loop of rebuilding, repushing the container image every single time. But for now, we'll do Docker build. We're going to increment it to 003. We're going to push. We're going to update our deployment. Then we're going to start, once that has finished cycling, we are almost there. Cool. Now we would expect our host name to show up. And so if we keep refreshing the page here, we see that the traffic is actually getting routed to the different pods, as shown by the different postfixes there within our cluster. And so hopefully this has given you an idea of like the minimum set of things that are required to get code from your local system and deploy that onto Kubernetes. And so just as a reminder of sort of what we ended up doing, this is all in the context of this series where I'm building out an application platform. I created a super simple API application, just kind of a hello world using FastAPI with Python. I took that, wrapped it in a container, pushed that container to DockerHub. I then created a cluster with Civo Cloud, which enabled me to get a cluster up and running. That cluster had 3 virtual machines running in their data center. And so Kubernetes allows me to abstract those virtual machines away, and I can just interact with them as a single cluster. I then took my application and put that image that I had built and pushed and put it inside of the Kubernetes-based resources that I needed. And so there I needed 3 things. I needed a deployment. So deployment tells Kubernetes how to run my container and what configuration and how many replicas. A service, which is the internal load balancer that allows network traffic to be routed across my different pods. And then thirdly, the ingress resource, which tells the ingress controller, in this case traffic, which was installed in my cluster by default. If you're provisioning a cluster elsewhere, you might have to install an ingress controller yourself. But to tell it, hey, for traffic coming in from kates.devopsdirective.com on the route path, route it to that service that we defined earlier. And so that allows that traffic to come external public internet, hit my cluster, Ingress controller routes it to the service routes it to one of those 3 pods, and then we saw it load balancing across as I refreshed the page, the different pods were getting the traffic. And so that's all for today. Hopefully that was helpful if you were just getting started with Kubernetes and sort of confused about what the steps were for getting your code from your local system into the remote cluster. Like I said, we did things manually today. A lot of this is going to be automated to help reduce the potential for human error. We'll also talk about improved developer workflows. I know this is a little bit different style than much of my more scripted content, but hopefully you found it helpful. If you enjoyed this and want to check out other videos in the series, there will be links to the playlist in the description. That's it for today. And remember, just keep building.